Statistics is all about data. In fact, data are the life and blood of statistics. I would argue that without data, in fact, there is no statistics. When it comes to data, it comes in all shapes and sizes. And if you have been paying attention to what is happening, what has been happening in the world as of late, especially around since 2010 and 11, you would notice that the real buzz is around big data. And corporations, governments, individuals, they all want to do something with big data, and they don't want to be seen without big data. In fact, a colleague and I wrote a paper in the International Journal of Information Management, and we critically looked at this concept of big data, and we called it Beyond the Hype because we realized that there was more hype to big data than what was in fact possible with it. In fact, I would argue that most companies and individuals would have what we call small data, something that fits on your hard drive or the hard drive of your computer, or something that you can work with a small server. And if you notice, a lot of data that we work with in real life, not just at universities and schools, is small to medium-sized data. And thinking of data, you have to realize how it's collected and how it's generated. A large number of data sets are collected through surveys. You have been a recipient of such um, unsolicited phone calls or people stopping you on the street asking you, can you spare 5 minutes for a survey? There are cross-sectional data. In fact, what happens is that from a random sample of individuals representing some population, we conduct a survey and ask them a question at a point in time, and in fact we get a cross section of opinions at that particular time. And another way of collecting data is to ask the same question to the same people repeatedly over a longer period, such as tracking children from the age of say 5 to their adolescence and all the way to their adulthood. So over a 30-year period, you test their IQ scores, their behavioral attitudes, their attitudes towards life, the choices they made for education and careers and family, and that kind of data would be longitudinal or panel data. Another kind of data that you are most likely to be familiar with is called time series data. If you look at housing prices, a graph of housing prices going up and down, or unemployment rate fluctuating over time, these are called time series data. You're collecting this information about the same entity over time. Um, what is called big data is essentially the web-based data or data that has been being continuously generated by smartphones or information technology enabled devices that keep generating this data automatically, and the size of that data is humongous, and that's why it's called big data. The data set, once it's in a tabular format, and that would be the focus of this statistics 101. That data has variables, and those variables would have certain types, and we'll discuss them later. Since business, analytics, and social sciences rely to a great deal on survey data, let us discuss it briefly. If you have been paying attention to the news or to television, you know that in the United States, we had the presidential elections, and what's happened is that for a very sustained period of time, the polls, that is, the surveys done of eligible voters, suggested that one candidate would win over the other. The odds of one candidate were significantly higher as per the survey data. But then it turned out at the night of election night, people realized that evening that the polls were horribly wrong. So survey data is very useful, but I would start with the caveat that the quality of data determines the quality of analysis. And while I'm mentioning these polls went wrong, I would like to mention Warren Mitofsky, who is one of the pioneers of exit polling data. And as we go along, I hope that we'll get a chance to revisit some of his work. But in the end of the day, you have many companies, individuals who collect data. Even the government collects data through polls. And the United States Census Bureau not only does census, which essentially is a survey of all individuals, or supposed to be a survey of all individuals in the U.S. And same is the case with the Census Bureaus or agencies in Europe and in other parts. Then there are professional organizations that do service for businesses and governments. Gallup is one such agency. And then there are think tanks or fact tanks such as the Pew Research Center that collect data on matters that are of importance sociologically, socially, or politically, or economically. One good thing about Pew Research Center is that it makes its data available to all. In this particular course, we will routinely use a data set from University of Texas, provided by Professor Daniel Hammermesh. Professor Hammermesh is an author and a celebrated economist who have been looking over the years as to how one's appearances or looks impact their economic or other outcomes. His book Beauty Pays is an interesting read, and I highly recommend it. The dataset looks as follows. We have beauty, which is the rating of the instructor's physical appearance by a panel of 6 students, and then teaching evaluation, which is the lowest could be 1 and highest could be 5. Notice that beauty and evaluation are continuous variables or real numbers. So evaluation could be 4.1, 4.2, they're not integers. Whereas minority status is sort of a factor variable or a categorical variable. It's either 1 or 0. If a person is a non-Caucasian or visible minority, 1, 0 otherwise. Then gender would also be a categorical variable, or a dichotomous that could take only one or the other value. So gender, native, tenure are all dichotomous variables. So we will discuss these types as we go along and as we work with data, but understanding the type of variable and the kind of analysis one can perform based on the type of variable is very important to get right from the word go.